Let's talk about linear functions. Now we're going to do that by looking at tables and equations and graphs. But before we do that, I want you to think about the word linear. Is there anything that stands out to you about that word? Yeah, line. So when we look at a linear function's graph, it will always have the shape of a line. For our first linear function, let's start with an equation. f of x equals 3x is a linear function. Let's make a table of values to find some points that we can put on our graph to see if we have the shape of a line. Because the domain of this function is all real numbers, we could put any number into the function for x. But let's make this easy on ourselves. Let's pick some easy numbers like 2 for x. Since 2 times 3 is 6, f of x is 6 when x is 2. When x is 3, 3 times 3 is 9. And when x is 4, 3 times 4 is 12. Now that we've got input-output pairs, let's use those as coordinates for points on the plane. And when we do that, we can see that those points do fall on a line, so we can connect the dots with a line. Now the reason why we can connect them is that the domain for this function is all real numbers. So all the x coordinates that we see for the points on this line could have been used as inputs, and we would have gotten the corresponding y coordinates for those points as the outputs. Okay, so we started with a linear equation, and we graphed the linear equation by making a table of values. In this case, let's start with the graph and see if we can find the equation for this line. Now we'll still look at some points along the line, and because there's an infinite number of points, we can choose whichever points are convenient for us. So let's make this easy. Let's pick some points that fall on the grid line so that we know what their coordinates are. And let's pick points that have really easy whole numbers. So for example, 1, 2, 2, 4, and 3, 6 all fall on that line. Now we're also choosing those points because the x coordinates do follow a nice pattern, and patterns can be really useful when we're trying to find equations. So let's see, when x was 1, y was 2. When x was 2, y was 4. When x was 3, y was 6. Okay, great. We've got the graph, we've got the table, now we need the equation. And to find the equation, we'll look for some patterns to see how do we go from an input to an output in our table. In other words, what do we do to 1 to turn it into 2? What do we do to 2 to turn it into 4? And what do we do to 3 to turn it into 6? Can you see that what we're doing is taking every input and doubling it to get the corresponding output? So our equation is that y, the output, is 2 times x, meaning 2 times the input. And to write that using function notation, we would say f of x equals 2x. Make sense so far? Okay, let's try another one. Let's start with a graph and then look for points that are easy to identify. So maybe 1, 3, 2, 6, 3, 9. Okay, so the x coordinates do follow a nice pattern. That can be useful. And the y coordinates that go along with those points are 3, 6, and 9. Okay, so far so good. But to get the equation, we're going to look for a pattern to see how we go from the inputs, the x, to the output, which is the y. So what do we do to 1 to turn it into 3? What do we do to 2 to turn it into 6? And what do we do to 3 to turn it into 9? Yeah, this time we're tripling all of our inputs. So our equation is y equals 3x. In other words, the output is 3 times the input. And to write that using function notation, we could say f of x equals 3x. Still make sense? Okay, now we're going to change this up a little bit. In this case, we're going to start with the table and see what the graph and the equation look like. Now, all we're going to do is change this table a little bit. So instead of saying the y is 3, 6, or 9, let's just add 1 to all of the y coordinates. We've still got input-output pairs that still follow a pattern. Let's go ahead and graph the points, though. So 1, 3 plus 1 is 4, 1, 4, 2, 6 plus 1 is 7, 2, 7, and 3, 9 plus 1, 9 plus 1 is 10. So 1, 4, 2, 7, 3, 10. Great, we've still got a line. Now, let's see if we can figure out what the equation is. So think about what we did. We started with the equation y equals 3x. And then we said, hey, let's just add 1 to all the outputs. In other words, add 1 to whatever we got when we took 3 times the input. Well, there we go. That's it. That's the equation of this line. Y equals 3x plus 1. And in function notation, that would be f of x equals 3x plus 1. Now, here's the thing about this equation. It's actually in a special form. There's something we call slope-intercept form for linear equations, which looks like this. F of x equals mx plus b. Do you see how this fits that pattern? F of x equals 3x plus 1. So in our equation for this line, the m is 3 and the b is 1. Now what we're going to see is that the m represents the slope of the line. That's a number that tells us something about the steepness of the line. And the b is called the y-intercept. It tells us where the line crosses the y-axis. Now look carefully at where this line does cross the y-axis. Can you see that it crosses at 1 on the y-axis? That's why the b is a 1 for the equation. We'll get more into the different forms for linear equations another time. But for now, let's just look at this relationship between the equations and the graphs and the tables for linear equations. So here's a linear equation. F of x equals negative 2x plus 7. Remember that slope-intercept form we talked about? Can you see that it does fit the pattern? F of x equals negative 2x, so the m is negative 2, the slope is negative 2, and b is 7. The y-intercept is 7. I expect this graph to cross the y-axis at 7. Well, let's see if it does. So before we graph the points, we need some points. So let's find some input-output pairs for this equation. And once again, let's make this easy on ourselves. Let's go ahead and put nice simple numbers in for our inputs. So 1, 2, and 3. Okay, let's find the matching outputs. So when x is 1, y is negative 2 times 1 plus 7, which is 5. So there's 1 point, 1, 5. When x is 2, y is negative 2 times 2 plus 7, which is 3. And when x is 3, y is negative 2 times 3 plus 7, which is 1. Okay, we've got 3 points on our line. We'll go ahead and graph them. 1, 5, 2, 3, 3, 1. Great, they do fall on a line. Let's connect the dots. Well, look at that. We did predict that this line would cross the y-axis at 7 because we noticed that the value for b in our equation was 7. Does that make sense? Great. Now we'll talk more about lines later on, but for now, just remember there's a relationship between the equation and the table and the graph for all linear equations.